Which of the following is the correct net ionic equation between aqueous barium chloride and aqueous sodium hydroxide? First thing we do is write a balanced molecular equation. So let's start with that. We have barium chloride plus sodium hydroxide, and this will be a double displacement reaction. So we will have barium hydroxide and we need two hydroxides because barium's valence is +2 and hydroxide is -1, so we'll put a 2 there. And also we'll note that this is a solid, and the reason that's a solid is hydroxide is not soluble. So we should have had aqueuses here and an aqueous here. And what's left over? We have sodium chloride, which is aqueous because that is soluble in water. Running out of room, but there we go. Now we have to balance it. We note that we have 2 chlorines on the left and only 1 on the right. So we'll put a 2 here in front of the sodium chloride. That now gives us 2 sodiums. There's only 1 on the left, so we'll put a 2 here also. So there's our balanced equation. Now we disassociate the aqueous components and show the ions. So this will be a little longer. This is our net ionic equation. Well, on our way to the net ionic equation. So we have barium, which is 2+, and that's aqueous, plus 2 chlorine minuses, also aqueous, and I'm just going to write an A there to save a little time and room, plus 2 sodiums, each one is +1, and that's aqueous, plus 2 hydroxides, minus, and that's aqueous. Now, barium hydroxide is a solid, so that will not disassociate. So we're just going to write that, barium hydroxide. There's 2 hydroxides, and that is a solid. And then we have sodium, and that's aqueous, plus chlorine, which is also aqueous. Now we cross out whatever is the same on the left as the right. So that's chlorine, chlorine, sodium, sodium, and what we're left with, and let's switch to another color here, we'll go to green. We have, let's see, we have the barium aqueous on the left, the hydroxide aqueous on the left, and then the precipitate barium hydroxide. So C is our answer.